Welcome to Module 18 on frequency tables. Right now, make sure you have your notebook out and that you have your pencil ready to write. You're going to want to take notes so that you don't have to look all these things up when you do your quizzes and tests. All right, new notebook page, Module 18 on frequency tables. So we're going to talk about how to construct a frequency table. We're going to learn how to compute percentages from a table of values. We're going to make inferences using a two-way frequency table, and we're going to calculate relative frequencies in a contingency table. So essentially, a two-way frequency table is just a way to organize the results of some sort of survey. So what we've asked is 64 students in grades 1 through 3, can you swim? The reason why this is two-way is because there's two pieces of data that we're collecting from each student. We're collecting their grade, which we list along the top column, and whether or not they can swim, which we put along the top row here, and we put the can you swim along the left-hand column. Essentially, the intersection here is where can swim and first grade come together. So I noticed that we have 12 students in the first grade, 15 students in the second grade, and 16 students in the third grade who can swim. So 12 goes here, 15 goes here, and 16 goes here. Then it says 6 students in first grade, 8 students in second grade, and 7 students in the third grade cannot swim. So 6 here, 8 here, and 7 here. This is just a way to organize our data. You can also find totals if we needed them. So we could see that we had 18 students in the first grade, 23 in the second grade, and 23 in the third grade. We could also add along the side, and we could see that we had 12 plus 15 plus 16 who can swim, and a total of 6 plus 8 plus 7, 21 who cannot swim. Something that's kind of cool about a frequency table is this number is the same for both the rows and the columns. So if I add all the totals of the grades, 18 plus 23 plus 23, I get 64. That's also what I get if I add the people who can swim to the people who can't swim. Sorry, that should have been a 4 here. What that means is I surveyed 64 total students, which, surprise, surprise, is what we started with. You pause the video and see if you can fill this in on your own. Bonus points if you can fill in the totals on each side. All right, so it says among the dog owners, 5 chose wet food and 11 chose dry food. So we're talking about just the dog owners. 5 fed them the wet food and 11 fed them the dry food. Among the cat owners, 14 chose the wet food and 12 chose the dry food. Again, this is called a two-way frequency table because we are recording two pieces of data for each survey, whether or not they have a dog or a cat and what kind of food they feed them. If we needed to, we could fill in these totals. We could find out that there were 16 total people who have a dog, 26 total people who have a cat, 19 people who feed their pets wet food, and 23 people who feed their pets dry food. If we add 19 and 23 or 16 and 26, guess what? We get a total of 42, which is where the 42 pet owners came from. Now let's step it up a little bit and see if we can fill in our labels on the top and on the sides. So we've got 44 students in the first or second grade that were asked, can you swim? So what we've got here is some students in the first or the second grade. So we can put first here and second here. You could have mixed them around, but it doesn't make sense to me to do that. It just seems more confusing. And then the survey is, can you swim or can you not swim? So it's can swim or cannot swim. Since both of these have two options, you could have put this either way. You could have flip-flopped it and had first and second grade along the side. And then along the top, you could have had can swim or can't swim as well. And then you could have filled in the boxes from there. If you filled it in like this, there are 11 students in the first grade and 17 students in the second grade that can swim, and 9 students in the first grade and 7 students in the second grade that cannot swim. If you needed your totals, there'd be a total of 20 students in the first grade, a total of 24 students in the second grade, a total of 28 students who can swim, and a total of 16 students who cannot swim. If you add those up, 20 plus 24 or 28 plus 16, you get 44, which is the 44 total students. If you did it the other way, then you'll have to think a little bit differently about it. There are 11 students in the first grade and 17 students in the second grade that can swim. There are 9 students in the first grade and 7 students in the second grade that cannot swim. And then your totals would have just switched sides. So it would have looked like that, but guess what? The overall total still stays the same. You pause the video and try this one on your own. All right, so your survey is again about pet owners. Again, every time we survey someone, we are asking them whether they have a dog or a cat, and then what type of food they want. So you could have set it up like this, or alternatively, you could have put the dog and the cat along the side, and the food along the top. If you set it up like this, there are 8 dog owners and 10 cat owners. Whoops, I put can't here, that should be cat. And 10 cat owners who chose wet food. If you do that here, it should be 8 and 10 like this. There were 11 dog owners and 16 cat owners that chose dry food. If you set yours up like this, it's 11 and 16. If you need the totals for some reason, then you can put 19 and 26, 18 and 27, and guess what? Your total is 45. Again, these are the same totals, 18 and 27, 18 and 27, 19 and 26, and a total of 45. Now, the reason why I started giving you the totals because we need those to calculate probabilities. So a new topic, calculating probabilities from a two-way frequency table. What we've got is a movie club that surveyed 150 high school students. So that's going to be important. What that means is my total over here would be 150. The students were asked how often they go to the movies and whether they prefer action movies or dramas. Their responses are summarized in the following table. So it says, what percentage of the students prefer dramas? Notice that it doesn't ask me anything about how often they go to the theater, to see a movie. It just asks about what percentage of the students prefer dramas. That means I need the total of dramas. So I need to add 55 and 35. That gives me 90. And so for A, my answer is 90 out of 150. To turn that into a percent, I divide top by bottom, so it's 90 divided by 150, and hit enter. That gives me 0.6. To change that to a percent, I move that 2 places to the right, so it's 1, 2. In the empty space, I have to put a 0, so that becomes 60%. For B, it says, what percentage of the students go to the movies twice a month or less? Notice it doesn't ask anything about action or drama. It only asks about twice a month or less, so we need the total of those. If I add 50 and 55, I get 105. And a percent should be out of my total, so it's 105 divided by 150, which is 0.7. If I move my decimal point 2 places to the right, then that percent is 70%. You pause the video and see if you can do this one on your own. All right, you should have noticed that your total is 250. It says, what percentage of the families are homeowners? Notice that A asks nothing about whether it's no car or one car, which means I need the total number of homeowners, which is 110. That's 110 out of 250. We're going to divide 110 by 250, and that gives me 0.44. If I move that decimal point 2 places to the right to change to a percent, it becomes 44%. And then B, what percentage of the family have 2 or more cars? Notice we're not interested in whether they're a homeowner or not a homeowner. There's a total of 180 who have 2 or more cars. So that means it's 180 out of 250. Notice in all of my fractions, it's out of 250 because that's the total. I end up with 0.72. I move that decimal point 2 places to the right, and I get 72%. All right, so there's no point in doing this if we can't make inferences, make decisions. So let's start with making inferences, make a new topic. And what we've got here is a total of 200 students who were asked whether they have a curfew and whether they have chores at home. A says, what percentage of the students have a curfew? Well, I can find the total that have a curfew. 29 plus 33 is 62. That's not a percentage, that's a total. It's 62 divided by 200 to get the percentage. That gives me 0.31, which is 31%. Then it says, what percentage of the students don't have chores? Well, that's also a total. I need to add 33 plus 77 and get 110 for the total number of who don't have chores. But that's not a percent. 110% would be more than everyone. That's not possible. We have 110 out of 200, so we divide that by 200. That gives me 0.55, which is 55%. Now, C is worded a little bit differently. It says, what percentage of the students who don't have chores? They're telling me we are only looking at this column. We are no longer talking about all the students, which means this is out of 110. What percentage of the students who don't have chores, which is 110, have a curfew? Well, that's 33 out of 110. So we're going to divide 33 by 110. That gives me 0.3. If I move that decimal point 2 places to the right, that's 30%. Now we've calculated all those percentages so that we can make some inferences. So what we want to know is there evidence that students who don't have chores tend to have a curfew more often than average? So the first one says no, because the percentage found in part C is about the same as the percentage found in part A. That seems possible, so I'm going to circle that, but check the rest. No, because the percentage found in part C is about the same as the percentage found in part B. No, I don't agree with that. 30 is not about the same as 55. Yes, because the percentage found in part C is much greater than the percentage found in part A. Well, that's not true. It's actually less. Or yes, because the percentage found in part C is much greater than the percentage found in part B. Well, that's also not true. So the only thing that's possible is we say that there cannot be evidence that students who don't have chores tend to have a curfew more often than average. You pause the video, and I want you to start just by finding your totals, and then we'll check those together. You should have started by adding 49 and 28, and that gives you a 77. 21 and 77 gives you 98. 49 and 21 gives you 70. And 28 and 77 gives you 105. The total of everything added together is 175. All right, you pause the video and see if you can find just A on your own now. All right, the question asks, what percentage of the adults exercise? Well, 77 out of 175 exercise. So we do 77 divided by 175. That gives me 0.44, which is 44%. You pause the video and try B on your own. The question was, what percentage of the adults are vegetarian? Well, there were 70 that were vegetarian altogether out of 175. So we do 70 divided by 175, and I get 0.4, which is the same thing as 40%. You pause the video and try C on your own. This is the one where the total has to change. It says, what percentage of the adults who are vegetarian? We don't care about the not vegetarian. We only care about the vegetarian, so my total is 70. And what percentage of those exercise? It would be 49 out of 70. So we do 49 divided by 70. We get 0.7, which is 70%. You pause the video and see if you can find your answer to that. All right, so the first one, yes, because the percentage found in part C is much greater than the percentage found in part A. Maybe. Yes, because the percentage found in part C is much greater than the percentage found in part B. Well, that's also true, so we're going to have to narrow that down a little bit. No, because the percentage found in part C is about the same as the percentage found in part A. That's not true. No, because the percentage found in part C is about the same as the percentage found in part B. That's not true. So let's see which one better answers the question. Is there evidence that adults who are vegetarian tend to be exercisers more often than average? Well, the question is about exercisers, not about vegetarians. So we want to compare part C to A, not part C to B. So we need to choose that one as our solution. All right, new topic, calculating relative frequencies. Relative frequencies. A sample of 273 adults is selected. The adults are classified according to their voter registration status and their preferred source of current events information. The results are given in the contingency table below. So the reason why this is calling it a contingency table instead of a two-way frequency table is because we have more options here. So we've got 273 total. It says, what is the relative frequency of adults in the sample who are not registered to vote? So we're looking at people who are not registered and prefer to obtain their information through television. And prefer to obtain their information through television. When they tell us to find the relative frequency, what they're asking us to do is find a percentage. So just like we're doing before, it's 35 out of the total. So it's 35 out of 273. We divide that, we get 0.128. If I round that to 2 decimal places, it doesn't ask for the percent. That's 0.13, and we're done there. You pause the video and see if you can try this one on your own. All right, welcome back. This time you've got a total of 301 students. We've got students who are being asked whether they're male or female and what their major is. This says among the business majors, so we're only looking at this column. Find the relative frequency of those who happen to be male. Round your answers to 2 decimal places. So it says among the business majors in the sample. So I don't want my overall total. I want just the business majors. So I want to add 36 and 37 and get 73. Then this should become, find the relative frequency of those who happen to be male. That's 37 out of 73. So we're going to divide 37 by 73, and we get 0.506, which means I need to round this to 0.51. And I'm realizing I made a silly mistake on the last problem, so I want to back up to it. No, I think we're okay here because we should use the total of 273. No, that one's fine. So it's important to read this question carefully and decide, are you using the overall total, which we were on the last one, but this one asks among the business majors only. So that's why we divided by 73 and not 301. Sorry for the confusion on that one. And you're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 18. You should now complete Module 18 practice problems by selecting Continue My Path. Don't forget to click on the explanation if you need some extra help, and log on and do quiz 18 when you're done with all the practice.